pretty special live for you guys planned. Um, Wait for some people to get into the chat, and we're gonna do a electrical inspection. Um, some of you guys won't like this one, but we're gonna show you why you can and can't do what was done in the video, and then we might load a members only video, uh, something that I walked myself. Show you guys plug spacing, things like that. What an actual house looks like under rough. And once we get about 60 people in here, we'll drop the bomb on this thing. But for now, we'll just get into a question. What's going on, Jamie True? So first I'm going to get my chat working. Got all my messages, not my top messages. And we're gonna do this savage style. Again, you guys aren't gonna like this one, but that's okay. I'm gonna give you guys a sneak peek of what we're getting ourselves into. And that's what we're doing electrical inspection on. So that's coming up. All right, so let's get this thing started. Now, we're gonna do this a little bit differently. If they're really obvious, I'm just gonna tell you what the answer is. What site is that so you can practice? It is called test.com. This is what I've used for all of my testing as far as what my licenses are required. I paid $60 just so we can do these together. I don't need any of these tests, but I like them. They're fun, and it keeps me in the book. And it's my job as an inspector to stay in the book. So every time I go on site, I educate while I'm out there. Yeah, it's not too bad. Commercial electric insulated screwdriver. That's what I started with back in like 2007. Appreciate that, Jamie. All right, so the continuous load is defined as, let me see if I can zoom out one more time. There. We know it's for 3 hours or more. And we're going to multiply by 1.25, 125%. Where are we going to find that? A couple of places we can find it. Let's look where I know where it is. Now, first off, this is a 23 test. I'm in my 2020 book because I'm very familiar with my 2020 book. And can you guys hear me all right? Because the microphone is a little bit further away, but we have testing. Hang on. Okay. Cool. All right, so yeah, I just got to go around the microphone this time. Should be in the top right of this book. I'm total recall photographic, whatever you want to call it. Total recall would be, going to a house and knowing exactly what I saw, like, a couple of weeks or months ago. I can absolutely do that. But I'm also very photographic in the code book where I know where things are before I turn the page. And every once in a while, they will change the location of my codes when a new book comes out. And it drives me crazy. But it used to be at the top right. I think it's in branch circuits or it's in the load calculations here. Going off the top of my head. But we could probably find it somewhere else here too. Are tabs and books useless or helpful long term? for anyone that's not in the book every day, they're very useful. For me, they get in the way. I tear my pages. My 2023 book. What's up, Shaka? My 2023 book is missing so many pages, and especially in my conductor properties and the back of the book and stuff. Tabs are useful, don't get me wrong. I can't use them in my books. I'm in my book too much and they get torn. All right, so next question. What's maximum distance allowed between supports by staple straps and hangers when installing non-metallic sheath cable NM? So obviously we're going to go to NM here. Let's go there. Yeah, Souls did not get his stuff back, man. So that is unfortunate. We're why am I going all the way over here? We're gonna go 334, 330 something, 330 something. That's 324. I always go to 334 and then kind of work my way backwards from there. There's 334 for Romex here, and now we're gonna look for supports specifically. And the cool thing about the code, usually 310, anything .10 is going to be a uses permitted. And then the supports is usually a 30 something, I believe. So we're looking for not permitted, unsupported, securing and supporting. There's the 30 there. So it looks like, what's the maximum distance allowed? I wonder if I can see the answer if I click it. So it looks like it's 4.5 feet, right? Support straps, hangers installed, intervals not to exceed 4.5 feet. So if I click on this, what's up, Jonathan? If I click on this, is it going to tell me? Nice. Okay, we're back. So there we go. That's the question. Answer. Infrared commercial industrial heating appliances shall have overcurrent protection not exceeding. We want to go to probably 420 or 422 for appliances. So let's go there. If you don't know where your codes are, we can always go to the back of the book. 1 foot from the device box. Let's go back. 1 foot from the device box. But what it's saying is, what's the maximum distance allowed between supports by staples? So yeah, you do want to be strapped within 12 inches of the box. But we are asking about in between supports. So it's 4.5 feet right there. And then flex is 4 feet. And the code was right here in the book when we were there. It just showed you 4.5. They're talking about to run a cable, yeah. Okay, appliances here. We're looking for oh, hang on, we're gonna go back. Infrared commercial industrial heating appliances. Okay, shall have overcurrent protection. So we're looking for infrared. There's electric heating. We're looking for infrared. So let's keep looking. I'm gonna turn on this light here. Should be on my monitor somewhere here. Nice. That makes it better. We are looking for heating. Here's central heating. I'm kind of skimming through this too, and you kind of have to get your test. Like you gotta kind of know where to look pretty quickly. Here's infrared here. And it looks like 300 watts. No, overcurrent protection. We're looking at overcurrent protection. So we could find this answer either in overcurrent protection. Appreciate I've gotten better since watching your channel, and I'm second year apprentice that does residential. That's awesome, man. You're probably better than most of the people I already inspect for. Just the fact that you being here, I can probably promise you that. I see some pretty crazy stuff, guys. Pretty crazy stuff, and it's getting bad out there, like really bad. Okay, infrared here. There's 300 watts. Nameplate marking, branch circuit. Kind of skimming for the word overcurrent protection right now is what we're doing. Let me go back over here. There's appliances. Disconnecting means. My boss tells me to do stuff that I know better. I tell him, well, I would like to do it this way, but I'll do it your way. Dang. I hate that. Yeah. It's funny, man. Whenever I had my own helper, man, and he was like he was awesome. He actually became my best friend. And I sold him my first house, not my last house, but my first house for like a really good price. And I took even more off because the foundation was needed to be fixed. And I said, "Hey, I can trick the inspector and you can deal with it yourself later. That way it doesn't go on your mortgage, or I can fix the foundation before I sell you the house." And we tricked the inspector. But let's see here. So this is surface heating here. And anyway, that guy was like my ride or die, right? Here's infrared here. And it says here not to exceed 50 amps. So we found the answer right there. So it should be 50 amps. If we click on this, is it 50? It is 50. Perfect. Next. Long story short, man, the dude got my I left the company, and then another guy got my helper that I trained so much. I had people that was like, I'll trade you 3 guys for Jermaine. And I was like, why don't you just train your helpers? You know, it's like I spent 2 years with Jermaine here. I don't care if you give me 3 guys, they're not going to be as useful. I've trained my guy, you know. And it was just funny. So whenever someone else got him, I was doing infrared, so I was in a completely different apartment, and I would go back to construction just to help out in industrial settings. And I see that guy, and he's like, "Hey, man, how do you get Jermaine to listen to you? He never listens to me. He always says Robert would have done it this way. Robert would have done it that way." I just started laughing, dude. I was like, "What do you mean, man? Jermaine doesn't listen to anybody." It was pretty funny. He thought I had the guy listening to me. The guy always argued with me. It's just too funny. Okay, what do we when ambient temperature is not a factor, size number 8, single copper conductor with type FEB insulation installed in free air. Jeez. Jeez. So, one of the unspoken rules for this stream is going to be we're not going to do too many calculations. We're not going to get stuck in calculations. If we can find it in the book in a table, that's one thing. I don't want to get stuck doing calculations for a long time. I want to get through as many questions as we can so we can see how to look at how to find the answers here. But let's see here. When ambient temperature is not a factor, size 8, single copper conductor with FEBP insulation installed in free air will have an ampacity. The only way I know how to do this is if we go to conductors, which is at the beginning of 300 here, right here, and we want to look at this insulation rating here, and we want to see what it's rated for. I think we're looking for FEBP or something. I don't even know what that is. FEBP. FEBP. I think he's doing okay there, Rodney. FEBP. Oh, here's a FPFH. Okay, here it is. Here, check it out. FEBP, and it's for 90 degrees Celsius. Now, this is kind of a trick question here. It's asking what the ampacity of the conductor, right? We still cannot install this under 90 degrees Celsius because our terminations are going to be rated at 75. So in the real world, you would have to install this on 75 degrees C, even if the conductor is rated at 90. But for the purpose of this test, we're going to treat this as if it's 90 degrees C wire. And we know we can do that because right here it says 90 degrees C, and that's the insulation there. And what we're going to do is go over here to not this chart, because it said we're not worried about ambient temperature. It's not a factor. So we're going to go to 90 degrees C. Oh, look at that. We could just went here. I didn't even know that was a thing. Interesting. So double confirmation here. 90 degrees C for sure. And number 8 is good for 55 amps. Now, all of our breakers and terminations are going to be listed at 75 typically, unless you get very special lugs. What's up, Cody Russell? How's it going? And so we would only be able to put this on a 50 amp breaker, technically speaking. But for the purpose of this answer, the answer is 55. So in a test, they're not going to ask, they might throw you a loop, but this answer should be 55. It says 80 because I don't know what happened. Let's see what happened. Number 8 conductors have a temperature rating of 90 and an ampacity of 80 when installed in free air. Oh, the free air. Okay, hang on. This is why you want to practice your test, because I don't think I've ever had to look up free air conductors in a test in my life, but I seem to recall there being something about free air here or here or here. So here's free air here. And frankly, I don't know which one we're going to look at, but I see free air here and I see free air here. So we would probably want to look up the rules on which table to use. But based on this one table here, it looks like 80. So we jumped the gun on the question, which is why we're doing this. So we know not to jump the gun on the question. Get used to not jumping the gun. So 310.17 right there. And so this looks like a suitable table to use for a question when they ask this. How do you get to this practice exam? It's hang on. Why can't I don't want to click back. I don't want to push that button. Hang on a second. It's called tests.com. You're right there. Tests.com. And you got to pay for it. Yo, what's up, Josh? Josh, you were just in time, buddy. We are going to if we get 20 more people in here, we are going to do something diabolical, which has to do with electrician you. we're gonna do electrical inspection on electrician use transformer. I don't think it's gonna fare well. All right. We're size 14 branch circuit conductors protected by 15 amp rated inverse time circuit breakers, supplies 3 20 amp rated duplex receptacles. This branch circuit. That is a very vague, open question there. Yeah, we're looking for 90 degrees C, not 200. So, um, yeah, I usually do hear good things about Dustin. You're not making this easy for me, man. There's like 7 things that I would fail as an electrical inspector on his transformer install, and I'm not trying to call the guy out, but also like, you got 800,000 subscribers. Yeah, dude, it's not a good look. We're gonna look at it real quick, very briefly. We go to about 50 people. We'll look at it here in a second. Okay, size 14 branch circuit conductors, 15 amp breaker, supplies 20 amp rated duplex receptacles. What's going on, Josh? I like the hierarchical thing. I don't even know what they're trying to ask for this question. It's a weird question. You will not get a question like this on your test, and also it'll be multiple choice. So we're size 14 branch circuit conductors protected by 15 amp breaker, inverse time circuit breaker. That's pretty much every circuit breaker, by the way. Um, 20 amp rated duplex receptacles. This branch circuit is maybe allowed or not allowed. Would NEC code compliant or not compliant. So what we can do, hardest thing I've seen with guys that's been doing trade for a long time is accepting when they're wrong. I would agree with that. I see it all the time, man. That's why whenever I present something, especially to these older guys in the field, I make sure to one, mind your P's and Q's, right? Because you shouldn't have a God complex out there. Unfortunately, a lot of inspectors do. But you want to present it, with code, obviously. What we're looking for now, we're gonna look at this receptacle here. So this is the loads here. And we're going to go to receptacle ratings because it's talking about receptacles and branch circuits. And we found this in branch circuits. And the answer is mayonnaise. Perfect. So we got a circuit rating, which means the breaker that it's on. And if you have a 20 or a 15 amp breaker, you can put it on a 15 amp receptacle. Now, if we have a 20 amp receptacle, we cannot put it on a 15 amp breaker. So let's say that in our head as we go look at this question. If we have a 20 amp receptacle, we cannot put it on a 15 amp breaker. Okay. If we have a 20 amp receptacle, which we do, we cannot put it on a 15 amp breaker. So this branch circuit is stupid. The answer is stupid right there. Not a good idea. Violates a violation. Okay. Survey says violation. As per table. See, not compliance. Perfect. A violation. We called it. The wire size is wrong. Let's look at that. We got the violation question right. So I'm not always right, but I'm never wrong. Dude, when somebody calls me up, I'll be in the office at the end of the day. They'll call the inspector and they'll say, "Hey, I saw it this way." Man, I love to talk about it because it's my chance to learn something. It's my chance to maybe see something different where I could be wrong. I'm rarely wrong, but I get of course, I don't want to be wrong. Nobody wants to be wrong, but it does not bother me, man. There's nothing wrong with being wrong. It's your chance to learn. It's your chance to better yourself, and it's something I enjoy the conversation. Somebody called me the other day, and I was doing an inspection for a pergola next to a pool, and they had I'll draw it out for you guys. It was pretty interesting. This one's actually pretty good, and the code is not consistent with the verbiage, so it's very confusing for somebody that does not regularly, be in the book. So what they had was we had a pool here, right? And we'll just say this section here was the roof that they built, right? And in this roof, they had a couple of can lights here and here and here and here. These were can lights. And then they put they had a fan here and a fan here. Now, what the code says about fans, because with your fans, you're going to have fan blades that are going to extend out, right? And I'm going to show you in pools where it talks about fans and pools and the clearances. But if this is a fan here, we've got to measure. If this is a pool, you got to measure 5 feet from the water's edge to the fan blade. So we're going to measure, from that's bad. Let's go yellow. We're going to measure from the water, out, and most people will measure to the box, but you can't measure to the box. You need to be proactive in this situation because this is going to be 680. Don't know off the top of my head what code it's going to be in. Let's look. In 680 dot. It's after 2 pages after this. Hang on, let me find it. Oh, I got to zoom out for you guys. Hang on. Come on, phone. You can do it. There we go. Oh, we went to PV. Huh. Went too far. We're looking for where it shows the diving board in the pool. I'm really photographic, so I don't have to look at this book. Here we go. So this is where it shows the pool here. And then we're going to look at our, we're going to go over here to measurements. I see measurements here. So we're seeing luminaires, outlets, ceiling fan, pedal fans. Now we have new outdoor installations and we have indoor clearances and things like this. This is new outdoor installations here. And what it says here is 5 foot horizontally. So it's in 680.22 B1. 680.22B1. And what it says here, in outdoor pool areas, luminaires, lighting outlets, and ceiling suspended paddle fans installed above the pool or area extending 5 feet horizontally from the side walls of the pool shall be installed at a height not less than 12 feet above the maximum water level. There's an exception to this rule here. And basically, if the pool is existing, you're allowed to GFCI protect the fan. So we got to find it here. Let me see if I can find it here. Permanently installed pools. There's a rule for it. It has to do with existing installations. And let me see if I can find it here. Existing installations. Here it is. Here, check it out. Existing luminaires and lighting outlets installed. Can be less than certain areas. And then also your GFCI protection in adjacent areas, luminaires, lighting fans, fans installed in the areas 5 feet and 10 feet horizontally shall be protected by GFCI. See here? So no, because in this case, this is a existing fan, and then we installed a pool. That's what this is. We already had the area in red first, and then we installed a pool. Okay. That's existing. What's not existing is if you have a pool first and then you install your fan. You have to have the fan first and you're installing a pool to be able to GFCI it. If you're the pool first and you want to install a fan, that's different. And that's where the exception doesn't apply. So that's where he couldn't do that. Now, what's really interesting with this code is that you're going to see here where it says the verbiage paddle there. So the guy was like, yeah, I appreciate it, man. Thank you. So what happened right here, if we zoom in so we can get you guys nice and close here. What happened here is this paddle fan wasn't here yet even. I was being really, really proactive with my rough inspection. And this is what I had to go off of. This is all I had to go off of was where his box was. And I took a measurement out and we were probably about 5 feet here. And his box was actually not within 5 feet. And I was like, man, by the time that you get a paddle on there, we're all gonna have a bad day when I gotta fail you for the final, and then the box is freaking installed, in the wood, because they tongue and groove the cedar nowadays. So, it's good to be proactive and take your time on these inspections to help some of these contractors out. So the remedy here was that he's not going to install a paddle fan. He's just going to install a light because the code doesn't say you can't have a fan rated box wherever you want. What it says is you can't put a ceiling fan. So he's going to put a light there, and then he'll still be not within the 5 feet. But the guy asked me, he said, "Hey, where do you see that it says the paddle portion?" And what I did was we went to 410, which is in Luminaires. So let's look at that. Microphone is fighting me a little bit. There we go. We're going to go to Luminaires in 410 here. And you're going to see a tub picture. Went too far. Okay. Should be a tub here somewhere. Or maybe that's in the handbook. For some reason, I thought it was in this code book, but it's probably in the handbook. It is the handbook that shows the tub. That's okay. Suspended fans here. And if we look for right here, bathtub shower areas, it says no parts of cord connected luminaires, chains, cables, or suspended paddle, and it's got the paddle in parentheses there, shall be located in the zone, right? So that's a bathtub, not even a pool. So when we look back at the 680.23, we're going to see, because this is the argument here. I was willing to have it for him. Why not? He said, where do you see where it says, why are you calling no part of the fixture? And I said, man, it says somewhere in the code, it says no part of a fixture. So I went where I knew where it was in 410, and I saw the word paddle. And we see the word paddle here. So if you had just a fan without a paddle and it wasn't within 5 feet, then we'd be good to go. But if you have a fan and then you add the paddle, now we're back within the 5 feet. So, and then they got the paddle here in parentheses there. So dead to rights, we can't have that fan there within 5 feet of the water's edge. When doing this. Now, if the pool is existing, because the pool is existing and we're adding this, we can't have it. If the fan was existing and we're adding the pool, we would likely be able to GFCI this outlet. Okay. Don't save. Let's look at this. The suspense is killing Josh here. I can tell. We are going to go to our desktop here. Okay, so we got 3 things here. This one's pretty big, guys. First off, in this video, we got taped grounds. So you can't tape a ground and re-identify it unless it's number 4 or larger. So if we go here to 250 here, 250 somewhere here, we got to look for, I think it's like 118 or something. Oh, there it is right there. Smaller than number 6 right there. So what it says here, let me see here. That's the installation, not the insulation. Hang on. I think it's 118, isn't it? Types of equipment grounding. Identification. Here it is here. Let's see. So it says, unless required elsewhere, equipment grounding conductors shall be permitted to be bared, covered, or insulated, and visually covered or insulated. Equipment grounding conductors shall have a continuous outer finish that is either green or green with 1 or more yellow stripes. Except as permitted in this section, conductors of insulation that is green or green with more stripes shall not be used for the neutral, or I'm sorry, the hot or the neutral. It says ungrounded or grounded circuit conductors. Now, you got some exceptions here, and what it's going to say, at the time of the installation, it's permitted. So we're looking for that here. It's going to say, we got to find it here, at the time. An insulated or covered conductor number 4 or larger shall be permitted at the time of installation to be permanently identified as an equipment grounding conductor at the end. It says you can do that, but you notice how it says it for number 4 only. Number 4 and larger is permitted at the time of installation. It doesn't say anything about number 6 or smaller. So you can't do it. It's this here. It's got to be green or green with a yellow stripe. And then when you're over number 4 is when we can identify. I appreciate you being here, Rodney. So this is why you can't do this. So right here, and if you have the handbook, which is really useful, man, the handbook is so useful because it has the what you call commentary of the code, and it flat out even just says you can't do it, which is great. The handbook is awesome because it just flat out says, hey, look, you can't do it. And rarely does a code ever do that. So the commentary is really useful in some certain situations. But yeah, number 4 larger is the only time you can identify. And then 200.6, exactly, 200.6 here at the very beginning here is verbatim what that other code is. So number 6 and smaller, and it says here it's going to be identified by the following. and it's going to have a white outer finish or a gray outer finish. And then when we go to number 4, it says number 4 at the time of installation can be re-identified. But we're talking number 6 here. So on these transformer conductors for the grounding here, you can't do it. You can't tape this. Right? All right. So next question. How do I get to the next question here? Hang on. So the next thing here is he was doing a calculation here, and what he came up with was 41.6 amps. He did 1.25, and he got 52 amps. And he says you're allowed to go up to the next breaker size. You can't do that. It's a secondary conductor. So first off, where do you get the handbook? You can probably get it on Amazon, but you can get it at like probably Walmart.com, honestly. I mean, you type in NEC handbook and you can get it. You just got to pay, a hefty price for it. If we go to the transformers here, which would be Article 450. Let's go to 450. And if we look at the rules for overcurrent protection, you're going to see here where you have to have secondary overcurrent protection. There's a bunch of rules. I don't think he followed them correctly because other people have commented in this video, not just me, about how you still need a secondary overcurrent protection. This is overcurrent protection for the secondary. What's it called? It's called the yeah, Joshua can hook you up with the PDF. Yeah. I got to be careful with that, being that I'm an inspector, man. I can't hook anybody up with anything. Actually, I can't even send because I work for a city, I can't even send anybody a picture of the handbook in an email because they could sue the city technically for stuff. So, as far as like copies of things, I can't touch it. But yeah, I don't even want to go down that road, be associated with it. But I can use it for this channel, kinda. But I can't get into distributing. Well, Josh can. What we're gonna see here is that here it is, overcurrent protection is set more than 250% of the rated secondary current. But there's a rule here that I'm looking for that says that you have to go to it's in where is it? It's in 400. It's in 400 in overcurrent protection. Talks about secondary conductors and how to protect them. 400.6 240.6, sorry. 240. Let's get that mixed up. 240 here. And if we look here, overcurrent, this is the taps. So you have taps and then you have secondary conductors. Let me go back one click. Okay. So in this case here, this guy's saying you're allowed to go up to the next standard size on the secondary of a transformer. Can I hold up the book? This book is not the handbook. This is just a 2020 code. We're going to look for secondary overcurrent protection here. And what we're going to see is pretty crazy here. So here's the secondary. And it's going to say right here, plain as day, okay? Not less than the combined calculated loads on the, not less than the rating of the equipment. So we can't be less than the rating. They can extend beyond the switchboard, the secondary conductors. The rating of the overcurrent device shall not exceed, let me see if I can find it here. There are rules for this stuff where you can't go to the next standard breaker, which is what he did. He went up instead of down. So I'm trying to find that right now. The secondary conductors are enclosed in a raceway. Secondary conductors not less than the combined calculated loads. You know that. But we're looking for the secondary protection here. It could be over here closer to the overcurrent device here. See if I can find it. It is here somewhere. We might have to Google it and cheat. You get a free load calculator for the purposes of a Makita tool. That's pretty legit right there. Taps applying, taps not over. Man, there's a rule when you do taps and you do secondary conductors. This mic is in my way. Hang on. Okay. So let's see if we can find it here. There's services. That's actually going to bug me if I can't find it because it's in here something plain as day, man. It says you can't go to the next standard size. Overcurrent devices being equal or greater than. That's what it says there. Verbatim for the taps. We need to find that. It says shall be equal or greater than the rating of the overcurrent device. We need to find that in the secondary conductors. There's taps there, not less than the combined loads, not less than the rating of the equipment, not less than the overcurrent protection device determination. So we're looking for the 10-foot tap rule, which is right here. The length does not exceed 10. The ampacity of the secondary conductor is. Secondary conductor shall be anybody know where it is? We can Google it in a second. We can go to another question. But this is the worst part here. This is the worst part of it all. You guys ready? This is the nail in the coffin. He's got two panels. He's got a 3-phase 125 amp Schneider QO here, right? And it's rated at 240 volts. And if we look at his other panel, he's got a 3-phase MLO of the same type where that's not 480 volt rated panel. So yeah, man, he's bringing 480 volts to a 208 panel. I mean, there it is there. It's MLO. It's got no overcurrent protection on the secondary side. And he's got 474 volts on a 240 volt rated panel. It's the whole thing's pretty insane, man. There's like 6 freaking violations on that video. Yeah. There you go. All right, next question. A 20-foot feeder tap for lighting has an ampacity of 150 amps. The maximum amp rating permitted for overcurrent protection device protecting the conductors for which they are tapped. Oh, this is what we're looking for. This is great. This is great. It's gonna be, well, we gotta do 1/3 of this, right? It's a 20-foot feeder tap. So we're actually already in taps, so that works. Let's do a tap. So we're not gonna go over 25 feet. So if we look at the is it industrial? Where is it? Lighting ampacity. Let's see here. Secondary here. This is the 10-foot tap rule. This is an industrial installation. This is the standard installation. Cool. 240.21B3. Let me look at B3 really quick. Just really quick. Supplying primary plus secondary. This is at 1/3 of the rating. Conductors, the transformer should have an ampacity that's not less than the value of the secondary total length. The primary and secondary conductors are protected from physical damage, and the secondary conductor refuses to limit the load. Not more than the conductor ampacity. Okay, so the maximum ampere rating is 150. Why is it asking that? It's saying the feeder tap for lighting has an ampacity of 150. What's the maximum rating permitted for an overcurrent protection device protecting the conductors? Oh, I see. So we can go 1/3 of this, I believe. I believe we can do 1/3 of this. Because what it's saying is the tap inside the box, the wire inside the gutter is good for 150. What size wire can we tap off of that 150 and then add overcurrent protection? So in this case, this is what we'd be looking at. We would be looking at a gutter. Where's my mouse? That is not a good gutter. Okay, we got a gutter here, right? There's some wire in here. We'll make it red just for simplicity here. We got some wire in here. It's rated at 150. Okay. This probably goes to other places, whatever it's doing. We want to be able to get a circuit off of this wire. It's got overcurrent protection before it, so the wire is protected. We want to tap a smaller wire off of this and run it up to a disconnect. It's 20 feet away. What is the maximum size? It doesn't say wire, it says overcurrent protection or rating. What's the rating of this that it can be? So we're going to figure out based on 1/3 of 150 amps. and then go from there. So let's see what we got. Maximum ampere rating permitted for overcurrent protection. So let's go to, I need a calculator actually. Someone do a third of 150 and tell me what it is. $50 amps, 49.5. Question is, can we go up to the next standard? We are 0.5. This could be a trick question. 50, 50, 50. Yeah, 50, I guess. I don't feel like there's a trick here. 50 amps. Oh. 1/3. What the hell are we doing here? What are they asking for? We did it backwards. It requires the ampacity of the tap connectors not less than 1/3 of the rating. Oh, we did read it wrong. When they said a lighting, I was thinking like a freaking light, like a small branch circuit. So that makes sense. These conductors here, this is what they were saying. This is why you got to pay attention to the wording. They were saying these conductors here are rated at 150. What rating are those guys? So Tommy Dickerson, they do this crap all the time, man. The test is so you multiply that by 3 to figure out what that rating is. That's, yeah, okay. That got me pretty good actually. Dang. What does it say? Less 150 amps tap conductors. Yeah. Yep. Okay. Disconnecting means shall be provided on the supply side of all fuses in circuits having a voltage over blank to ground. Probably 150. Yeah, 150 by 3. Yeah, it's obviously 50. Yeah. I don't know where I was at in the book with that. Okay, so let's see here. Let's go to we can look in fuses still. Let's look over here in fuses real quick. Feeders, fuses, circuit breakers. There's tap conductors, ampacities. Looking for like a rating or something. Overcurrent protection, thermal, fuse. You use the 80% rule for breakers. The 80% rule is yeah, for continuous loads and stuff. Yeah. I could find that for you. Why they're not multi-choice? Because we're on hard mode, I guess. We're doing the flashcards. Is there multiple choice on the oh yeah, there is if we go to test mode. But there's a rule for that maximum if we go to branch circuits here. There's a general rule. of what you're talking about here. See if I can find it here. Branch circuits. Port and plug. There's the continuous and non-continuous. 1.25 continuous. Let me zoom out again. Right there. That's the terminals of lamp holders. Let's go to the next one. Outside overhead spans of open conductors of not over 1,000 volts should have a clearance of not less than blank from signs, chimneys, and television antennas. Appreciate it, Rodney. Outside overhead spans of open conductors. So let's go to 225, which is should be outdoor branch circuits, I think. Because 220 is branch circuits, but if we go to 225, outside branch circuits. And if we look in here, we should get a little something like this. This is clearances from roadways, walkways, rail, and open land. But we should get another chart here. Right here. So that's over buildings and structures. Let's see here. Outside overhead spans of open conductors of not over 1,000 volts shall have a clearance not less than signs, chimneys, and television antennas. Let's look. Rail, water, open land. It's gonna be here. Let's look for clearances real quick. We're back in branch circuits. Hang on. 1,000 volts, supports over buildings. Clearances right there. Above grade sidewalks. Residential property. Above roofs. Overhead spans, open conductors, and open multi-conductor cable shall have vertical clearance of 8'6" above the roof surface, and then 3 feet in all directions. We're looking specifically for these things: chimneys, televisions, and antennas. Let's see if we can find it in here. Seems like we're supposed to figure out that a chimney would probably be 3 feet because of consistency with the code, but it could be a specific question, I guess. So we're going to do our diligence here. But it does say 3 feet in all directions and then 8'6" above the roof. Is it open overhead spans of open conductors not over 1,000 volts? So it could be 8'6", man. It says above roof surface though, and I wouldn't say that a chimney and an antenna is a roof surface. But then you got a vertical clearance here, 3 feet of platforms here. Clearance from windows. That we know that's 3 feet right there. Vegetation. Oh, here we go. What's that? Nothing. You want to say 3 feet, guys? I'm thinking 3 feet, probably. This would be one of those questions where I feel like they freaking screwed me over in the test, and I probably didn't get the question right. We're gonna go for 3 feet because this would be a good question for a test. Let's try this. An above roof surface subject to pedestrian, no. Voltage between conductors, no. Vertical clearance. I guess we're gonna go with 3 feet. I'm trying to be able to change pages as fast as you. Yeah. I just know where everything is, man. It helps. 3 feet. Hell yeah, we did it. Where do they call it though? 225.19b. Let's find that. B. Doesn't exactly say that specifically. Now, sorry, as horizontal. It doesn't exactly say that in my 20. It might say it in the 23 because this is a 23 test and we're in a 20 code book. I kind of want to look at that 225.19b. Hang on a second. Never mind. I thought my code book was in here. It's in the other room. We're not going to worry about it. But yeah, it was 3 feet. We still got the question right. Uh, we did this last time, and I think it was 100 amps, but it could have been 60. I can't remember. We've already done this one. We're moving on. Let's go with 100. We got it. Next. Where type NM cable passes through a floor, the cable shall be enclosed in an approved conduit extending at least blank above the floor. Your whole test, your journeyman's test especially, is going to be on stuff like this. Uh, Majority of your tests, out of 70 questions, probably 40 questions are going to be out of Article 300. It's going to ask you about clearances underneath corrugated metal roofs, which is 1.5 inches. It's going to ask you about board studs, which is 1.25 inches. It's going to ask you about the thickness of nail plates. It's going to ask you about uh, box finish surfaces. It's going to ask you all that stuff. It's going to be in 300. So let's look this up. If we go here to 300, it also says NM cable though. So we might want to go to NM now I'm looking at it. But we're also going to look in 300 because that's wiring methods. So let's look at protection from physical damage, which is usually here somewhere in the general requirements. See, here's one here emerging from grade where the enclosure race space subject to physical damage. There's fittings. It's probably not going to be here. Non-metallic sheath cable. There's the board holes, the notches in the wood, all the things I was telling you about. Let's go to 334 because it says NM cable. That's always a good hint on where to start looking. Let's go 334. And we're looking for passes through a floor. So we're going to go to protection from physical damage, passing through a floor, and then 6 inches right there. So it says we can do EMT, we can do Schedule 80 PVC, RTRC. I don't even know what that is. And then you got 6 inches above the floor. So the answer is going to be 6 inches above the floor. There you go. And 334 15B is where we're at. 334 15B. Oh, what's the next one? For temporary wiring installations at a construction site, have an assured equipment grounding conductor program. All required tests shall be performed at intervals not exceeding. So 590 is going to be where we're going to find temporary installations. So we're just going to jump over here to 590. Or not, all the pages are like really close. 590 temporary installations. And you could go in the back of the book and we could look up temporary installations. If we look at temporary installations, we go in the back of the book here and you would see. And this is really the only way you're going to get good at knowing where everything is. You know, you could use the tabs. You can have tabs in the test. Actually, I would recommend you have tabs. But they just get in my way. So I can't do tabs. I'm in my book way too much. So we're looking for assured equipment grounding conductor program. That's going to be pretty easy to find. And here it is here. And it says, shall be performed at intervals not exceeding. Probably going to be pretty close to verbatim here. Intervals not exceeding 3 months right there. So if you guys don't know what this is in the OSHA requirements, the Occupational Safety and Health Administration. And I can't remember what the colors are, right? But this is where that's required. If you've ever been in a larger outfit, like a very large company, they require you to take a multimeter and you have to verify the continuity of the ground conductor on the male end of the cord and the female end of the cord. And you got to take a multimeter and you got to sign off and check that you check the cord. You got to check your threaders and your band saws and stuff. You got to check the case of the tool to the ground conductor, unless it's double grounded. And then in that case, you just put insulated tool. And then you wrap a color of tape around that extension cord. And it might be like, you might start off with yellow, and the next month it'll be red, and the next month it'll be orange. And then the orange gets changed to blue, and then the blue gets changed to whatever it is. And every 3 months, you check all that stuff. Some companies will have it every month. Some companies will have it every 3 months. Just depends on what it is. And they'll have the E1, the lowest rank on the totem pole. He'll go check that cord. And if you replace the cord cap, you have to put brown tape on it. So if you ever go to a construction site and you've got a cord with a cord cap on it, and it doesn't have brown electrical tape on it, and it's been repaired, that's an OSHA fine. Could be, usually is. Would homeowner recommend a Hercules hammer drill and impact over the Makita? Probably. Mediocre. If Makita went to JF, the bear would get confused. Yeah. Harbor Freight acquires Makita Tool Corp for $17. Oh man. Okay. Sounds like an OSHA 30, probably. Circuit that supplies outline systems containing incandescent luminaires shall be rated to not exceed. Um, this is a question. They usually ask it a different way, but this is definitely on the test. So let's find it. We know that it's going to be. Oh, this says outline, not outside. Outline lighting systems. That could be a 410 and a luminaire. I was thinking a branch circuit, but it says outline lighting systems. That's probably something else. Let's say circuits, though. Let's look at 410 in luminaires and see what we can find here. It's going to be a hard question. 410, and we've got a bunch of luminaires here because we're in luminaires. 410. Luminaires enclosed closets, combustible material. Let's go to the beginning of luminaires so we don't miss anything. And we're just going to skip around very quickly. Luminaires together, listed, raceways. We're looking for outline. Outline. Now you got to be careful because they'll take, you might not know, but a certain luminaire might be called an outline luminaire, and they'll play with that. They'll know that an outline lighting system is a blah 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 luminaire. And unless you start like really reading inside the text, you won't know that what they're talking about is an outline luminaire until it's too late. So let's see here. Switching enclosures, double. That's installation of lamp holders. Bushings, rating. There's a marking. There's incandescent. Incandescent luminaire saw thermal protection. Clearances, installation. We might not find this one. General. Metal halide, remote. Go to the next page here. Looking for outline luminaire. Lamp holders. This is what we're looking for. Circuits to supply outline lighting systems. We're probably going to go to circuits, but I figured I would look in luminaires. We could be completely chasing our tail here. These are decorative lighting and similar accessories. General lighting. Grounding, fitting, support, hazardous. I don't know what an outline luminaire is, so we're going to go to circuits. We're going to go to branch circuits because we have no other choice. So now we're going to look for lighting in branch circuits. Here's lighting outlet here. We need to find more lighting circuits. Bathroom, garage, dwelling, dormitory. Receptacles. We're back in feeders now. Branch circuit. Here's a spot here. Here's a sign and outline lighting. We found it right here. We found it in branch circuit feeder and load calculations here. I just remembered that there was something about show windows right here. So what it says here, sign. Oh, sign. Outline lighting systems is a sign. See how they do this crap? So we got to go to Article 600. Check this out. If we look here, sign and outline lighting outlets shall be calculated a minimum of 1200 VA for each branch circuit. So now we can go to Article 600 because we found out that this is a sign. This is exactly what I was talking about. They're tricky like that. So we're going to go to sign here, which is 600. This was a really, really good practice question. Let's go 600 here. Check it out. Look at that. Sign, electric signs and outline lighting. So we probably could have went to the back of the book now and found outline lighting. Sounds and outline lighting systems. And we got to see here listings. Post sign. We're looking for the branch circuit right here. 20 amps. Now we kind of already knew it was going to be 20 amps, but let's see here. Each commercial building shall be supplied a sign outline that shall not be required for deliveries. Maybe it's not 20 amps. Keep looking. Branch circuit supplying signs rated in accordance shall be outline lighting. Keep looking. We are in the weeds now. Okay, ballast. So we're looking at incandescent luminaires specifically. So we need to find that too. Looking for incandescent signs. All right, man. I don't know if we're gonna find it. Trojan makes good overload protection. Yeah, not a bad idea for a fuse company. So we saw where it can't be over 1200 VA. I would say that they can't exceed. I mean, I would say 20 amps just based on what we saw there. Each sign, outline lighting. Oh my goodness, man. Location, point of entry within sight. Signs. I'm kind of done with this question. This is crazy. Circuits that supply outline lighting systems containing incandescent luminaires shall be rated to not exceed. Oh, their current rating. That's what it's going to say. I bet you it's going to say their current rating. That's going to be the freaking answer to the question. I bet you there's no specific number. It's just going to say the marked field installation current rating or some stupid shoot like that, man. I bet you that's what it's going to say, or we're going to go with 20 amps. If this was multiple choice, it'd be an obvious answer. What in the heck, dude? It's going to say their current rating. You ready? 20 amps. Okay, good. 600.5 C2. Where is it? 600.5 C2. This is exactly where we were, and we saw that right there. So we already found the answer. Cool. All right. The FLC. Size of the for a motor using continuous duty application. The motor nameplate current rating is used to determine the size of the full load current. FLC. I bet it's FLC. Determine the size of the. We're getting off in the weeds here with these questions because it's not obviously they're looking for a number. I'm going to go with full load current required for the motor. That doesn't really make sense. For a motor using continuous duty, the motor nameplate current rating is used to determine the overcurrent protection, the size of the fuse, breaker. It's not overload protection because overload is different. I'm going to go with the full load current, the amperage, whatever, fuse, overload protection. Okay. So a motor in a continuous duty application, the motor nameplate current rating is used to determine the size. Continuous duty, the motor nameplate current rating. Okay, so you look at the nameplate on the current rating, and that's going to get you your overload. Okay. For the purpose of determining conductor fill in a device box switch, three-way switch is counted as equal to blank conductors based on the largest conductor. Equal to what conductors? I found some more commercial electric on clearance, a depot, 3-piece insulated screw set. Yeah, that's pretty good. All of a sudden you want to watch Rain Man. For the purpose of determining conductor fill in a device box, a single pole three-way switch is counted as equal to a three-way. Oh, dang it. I was going to say a double volume allowance. I didn't mean to click that. I can show you where it is, though. It's in 314. And it's going to say double volume allowance for a yoke. So if we go to the rules for this, should be right here. Conductor fill. And then if we look at devices here, it's going to say each yoke or strap containing one or more devices, they're given a double volume allowance in accordance. So that's where they got two. What size? 20 amp overload protection short circuit. What wire type equipment ground conductor? What size equipment ground conductor is required for 5 horsepower, 3-phase, 208-volt motor having 20 amp rated overload protection and a branch circuit short at 30 amps? Well, you know it's a number 10 because you can go all the way up to 60 amps with number 10. But let's look this up. It's 5 horsepower, 3-phase, it's 208. We're going to go to the FLC table in should be 450 430.1. This one here. FLC, we go 5. We go to 208 volts here. Hang on, wrong page. There we go. FLC, we go to 5. We go 208 volts. And you can see what type of motor is it? It is a 5 horsepower 3-phase. Well, 208 is 3-phase, so we know we're in the right spot. Yep, we're going to go with number 10 all day. Although we could get away with number 12. But based on 30 amps, man, we got to go with number 10. This is a trick question. We're going to go with number 10. We did it. Number 10. So given the size, they're based on the overcurrent protected device. I don't feel like they gave us an overcurrent protected device. They said it had ground fault protection, branch circuit, short circuit, and ground fault protection. Yeah, okay, so they did. We got it right. 125, I think. Unless exceptions are consideration where feeder conductors of more than 1000 volts supply a continuous load of 240, the feeder conductors are required to have an ampacity of at least. So if we go to branch circuits and we want to go over 1000 volts this time, which isn't something we usually do, but we're doing it here. So we're going to go to 220 right here. And then we're going to look at, I don't want to go to feeders. I want to stay in branch circuits. And we're going to look for over 1000 volts here. If we ever find it. There it is right there. And we want to, it's here somewhere. It says 125. For feeder conductors of not more than 1000 volts. So it's not more than. Oh, well, that's over. So not more than is not 1000. So that's under. Not more than is under 1000 volts. Continuous load 240. Okay, so if we take 240 times 1.25 should be the answer. Either they're looking for a number or they're looking for a percentage. Let's figure it out. We'll do both just in case. So we'll do 240 times 1.25 equals 300. So we can go with either 300 or 1.25 for the answer. I think it's going to be 300. 300. Cool. We did it. Next. Okay. So classifications. We can go to Article 500. And we're looking for flammable liquid produced vapors or combustible liquid produced vapors. And they're explosive or ignitable. So we're going to go to Article 500 here. And what we're going to find is that a Class 1 Division 2 is flammable gases, flammable liquid produced vapors. What is this? Flammable liquid vapors, combustible liquid. So that's not what we're looking for. This is combustible dust. This is dust. So Class 2 is dust. Class 1, flammable gases, flammable liquid produced vapors, or combustible liquid. Combustible liquid. So this is going to be a Class 1. So Class 1 for the answer. There it is right there. So we went to classifications. You just got to read what they are. This is really daunting. Don't let it confuse you with all these classifications and divisions. You just got to jump in and read what it says. It says a Class 1. It's going to scare you with the division. The division has to do with the threat. So Class 1 is ignitable concentrations of flammable gas and liquid. And then a Class 2 has to do with dust. And then a Class 3 has to do with ignitable fibers. And then when you get to your divisions, that's when it talks about the area. But the class is what the threat is. And then the division is the environment that it's in. So you can have ignitable concentrations of flammable gases. And it'll have scenarios here. But you just got to look here at what each one is. So the class 1 is the flammable liquid and gases. The class 2 is usually dust, combustible dust right there. Class 3 is presence of easy ignitable fibers. And then you go through the divisions, and it talks about the different divisions. And then you just got to take your time and read through it. Uh, PV shall not be smaller than 10. I already know it's 10. We're just going to put 10. Let's do it. 14. Perfect. We could have looked that up, but we're out of here. Jeremy Stone just got a 67 on your C10 in California. Needed a 69. So it was awesome for the help. Well, Jeremy, we'll do 2 more for you. We're not going to rush this last question. So, keep at it, man. Just reschedule that test and do it again. And don't give up. Okay. Non-locking type, which is tamper-proof. No, it's not. No, it's not. That's not true. Non-locking type, 125 volt, 15, 20 amp receptacles located in guest rooms, and motels and the common areas shall be listed. The answer is probably tamper-proof, but we will look at the options here. If we go to receptacles and we look in guest rooms, we're going to go here to receptacles, which is 406. 404 is switches, 406 is receptacles, 408 is panel boards. So we're going to go to 406 receptacles, and then we're going to look at the locations. Let's see if we can find a location here. Receptacle orientation. There's some locations. Tamper-proof here. So what it says here, guest rooms, guest suites, motels, and hotels in the common areas. Tamper-resistant receptacles. Holy crap, we're close. Hang on. So right there, it's going to be tamper-resistant receptacles. Should be the answer. Tamper-resistant. There we go. Next question. Premise wiring system supplied by a grounded AC electrical service shall have a grounding electrode conductor connected. Wow, what a terrible way to word this. There's so many things this could be. Premise wiring supplied by a grounded AC electrical service shall have the grounding electrode conductor connected to the grounded, to the neutral, to the first means of disconnect, to the service equipment like what do they want here? You know, it's going to be to the neutral. But let's look at it. We're going to go to the beginning of 250. Appreciate it, Jamie True. Let's go here to Article 250, the beginning of it, when it talks about where we're going to attach this stuff. And if we look at the rules for the connection, one more. Bonding, grounding, system grounding, general requirements. There's so many ways that it could be. What it all has to do with is going back to the neutral. So let's look here. Bonding, non-current carrying, the grounding equipment manner that creates low impedance path to the ground fault. This is a hard question because it's so obvious what it is. If it was multiple choice, we'd probably already be done. But I don't know what they're asking for. For a grounding system, There is the grounded shall be bonded to the grounding. Like it just says it right there. I don't see, like, there's the enclosure. We got the enclosure, the disconnect, the grounded conductor shall be routed with the we're just gonna go with one of these, the main bonding jumper, the system bonding jumper. I'm just gonna say the neutral or the grounding shall be connected with a main bonding jumper with a wire or bus bar. Shall be contact at the first means of disconnect. Man, there's so many ways this could go. Let's see what it says. To the grounded service conductor. We got it. Yeah, grounded. That's the neutral, by the way. What's the maximum distance between supports? Straight runs a threaded trade size 2-inch rigid RMC. This one's pretty good. If we go to RMC, which is, I always go to 334 because I know where the Romex is. But what's kind of funny is that Romex is not where this all starts. It actually starts at rigid. So if we go here to like 336, let's see here, 334, 330. I'm gonna go back here until we find rigid. Gonna miss it. FC, AC, metal clad. That's MC, MI, and then TC, tray cable, SE, IMC. Okay. RMC, rigid here. And we're going to look at, this is the sizes here, but we got to find the supports. And there's the supports here. And then if we look at this, it talks about 20 feet, but it said something about 2 inches. So if we look here at 2 inches, rigid metal conduit, we're going to see here that 2-inch is going to be at 16 feet. So this is going to be maximum distance permitted between supports of straight runs. This is going to be a trick question because it's a maximum distance. So the exceptions are if you don't have support, so this is vertical risers, 20 feet. We're looking for straight runs, which would be, I guess, horizontal. So if we look at straight runs here, in accordance with the table provided, and if we go to this table, you're going to look at 16 feet right there. So it should be 16 feet. All right. And that's how you do that. A listed blank shall be installed in or on all emergency systems, switchboards, and panel boards. Oh, what? A listed blank shall be installed in or on all emergency systems, switchboards, and panel boards. A listed what? A listed that could literally be anything. I'm trying to think what that would be. A listed. Let's go to switchboard and panel boards and see what the stupid question is asking us. Some of these questions are not very good, but they do keep you on your toes. So we still like it. Let's go to 408, which is panel boards. Switchboard, switchgear, panel boards. And let's see if we can find something about emergency systems. We might need to go to 700 for emergency systems, but we're going to try here first. We're going to go as basic as possible and then work our way up. So I don't see anything about emergency systems here. Let's go to 700, which is emergency systems. I think 700 is emergency systems. I can't freaking remember. Yeah, there we go. And let's see here. We're looking for panel boards. We're just going to skim this for panel boards. That's all we're going to do. That is it. Components. What a terrible question. Storage, battery. I don't even know. What a terrible question. A listed blank shall be installed in or on all emergency systems. How about a listed generator? A listed power source, a listed backup system, a listed transfer switch. No, because that's, I don't know. I give up. Let's see. Surge protection. Okay. 700.8. So we were in 700. We just skipped over it. So we're 700.8. Where did I miss it? I'd be so pissed if I got that question on my desk. 700.8. Surge protection. Wow. And it doesn't even talk about panel boards first. It just says it right there. Nice. Now, what would happen in the test, right? This is how you do this. On the test, it's going to give you multiple choice. It's going to have 4 different, suggestions, and you're going to cross check all those suggestions. So if you saw surge protection, you would be able to start searching for surge protection and find it. If you saw transfer switch, you would be able to find all this verbatim. These aren't multiple choice because it just makes it that much harder and makes my life miserable. So we did it. Cables installed electrically heated floors in bathrooms, kitchens, hydro massage locations shall be. I already know it's GFCI protected, but let's look it up. If we're looking for electrically heated floors, hydro massage bathtub locations, honestly, I don't even know where you would start to look for that. Yeah, you get books on your test. You should get books. The NEC. You're taking a test without a book. That's pretty impressive. Although for my ICCs, man, you're supposed to use the IRC book for the International Residential Code, and it has like pictures and stuff. But I just used my code book because I knew the code book so well. Let's go to GSCI protection because probably in one of the options it would be in there for GSCI, and then we could cross check it. We're going to look for ground fault protection, and what we're going to see would probably be something in here. Laundry specific appliances. Fixed electric space heating. Where is it here? It's in this list of things. We just gotta find it. Garage. I know it's in this portion of the code, so I'm like just actively searching for it, but I don't know exactly where it is. Let's see here. We can look in specific appliances, but I don't think it's going to be. We can try appliances, or we can try. Trying to think where that code is there. Laundry, dwelling units. Fixed space heating equipment. Let's look for heated floors in here. Fixed electric space heating. More fixed electric heating. This is under floor covering. Fixed resistance electrode industrial processing. It's probably going to be here somewhere. GFCI protection. In addition to the requirements, the branch circuit supplying the heating panel or heating panel set shall have ground fault circuit interruption. So if we look at under floor covering right there, fixed heating panels or panel sets installed under a floor covering. So that would be GSI protection 42444E, which is where we're at. 424. This book is slightly different. Let's see if it's over here. 44. 44 E 42444. This is cables, heating cables. It's all the same thing. All this stuff requires GFCI protection. Just something good to know if you guys didn't. It's probably because this is a 23 code. Right there. It's probably close enough. But yeah, we got it. It's GFCI. Your C10, yeah. No, I got you. Look it up. It's a closed book test. Dang. What is a C10? Is that a contractor test? Cables install electric heated floors. Oh, we just did that. This is a ballast part of a luminaire. Within 3 inches of a ballast, a conductor shall have a temperature rating of at least. This is a good question, but we got to go. So we got to go, but I'm gonna look it up while I'm talking to you guys. Contractor's license, nice. That's what you need in California, I guess. If we were to look this up very quickly, we would look for ratings, temperature limit here, location, temperature limit of conductors. It'd be in here somewhere. Adjustable. That's grounding. It's not going to be in there. Branch circuit conductors are installed inside of a ballast compartment of a luminaire. Could be in branch circuits too, you know. I see something here near combustible. That's 90 degrees C. Ah, we can look in branch circuits, or we could look in because it's branch circuit conductors. They're not really talking about luminaires, but because it talked about luminaires, we want to check it. If that makes sense. Um, There's wiring of luminaires here. Tension, stranding, splices, stems. Uh, it might still be here. Take care of that KS. Yeah. Uh, Man, we gotta go. We gotta go. I thought I was gonna find this one pretty quick, but maybe not. Let's go 220 here. Let's go 220. 210. 210, and we can look in lamp holders here. Clamp circuits, branch circuits, cord and plug. That's required outlets. That's not it. Let's go over here to specific appliances. No, it's going to be luminaires. But it's going to be 90 because that's what the code's based off of. I'm going to say, well, no, might be more than that. Could be the 90 degrees C. I'm going to make a guess here. I'm going to say a 90 degrees C. Conductors, 90 degrees C. There you go. 410.68, which is where we were. Some of these things you just don't have to look up. You just know them. 410.68. Where were we? 68, 64, 68. Branch circuit conductors and ballasts. There you go, right there. What license do I carry? I've got a Texas journeyman's license, 4 ICCs, and a level 2 infrared. So I'm going to be taking my master's sometime soon. I wanted to secure all of my ICCs first, which is what gets you paid as an electrical inspector. So ICCs is the name of the game when you're doing inspections, and they are somewhat difficult. So once you get your first ICC for residential, you need to get your commercial, and then you got to get 2 more certs to become a senior status, and you got to be working for the municipal for like 5 years. So I want to take care of all that first, and now I will probably start to get my master's. Although I don't know if I even want my own company. I kind of want to have a master's to say I've got it, but it's a lot of fun not having a master's and just flying through this code book. So I don't know if I'm going to take the test or not. I was studying for it when my mom passed away, and I was doing infrared, and kind of took a step back and looked at what I was doing, with safety and what I was involved in, because I was literally laying in the bottom of switch gears, all suited up, just wrapping my arms around, 3,000 amps of wire and running a cable in between to get the amperage readings. And opened up all kinds of hot equipment, and some of the stuff would open. The suit would give you an open casket, but the pressure would still, destroy your organs inside the suit. So some of the stuff you'd open, like the hot suit, doesn't even help. Um, so I stopped doing that, and then once my mom passed away, pretty much moved out here where I'm at now. And then once I moved, I found my 10,000 hour letter, uh, all the paperwork that I needed to take the test. Like all I had to do was just mail it. And when I found it, I just tore it all up because it was all old at that point. So I don't know what I'm gonna do. Um, I suppose master's the next step. I've heard, I don't know if this is true, but some places won't hire you if you have a master's because they don't want you to take that position. And sometimes if you put a master, it's seen as a negative. I don't have a problem getting it. I wouldn't have a problem getting it. Um, I sit these tests for the masters and usually get about a 90. If I want to sit down for 2.5 hours and actually do one of these, um, I'll get a 90. And then the ICCs are harder than any journeymans. I'm not worried about getting my masters. I would have to keep my journeymans too. So I'd have to get a master's and a journeyman's and keep them both. And in some cases, you don't want to tell the shop that you're working for that you have a master's, although they can look you up because they don't want you doing side work. So that comes up a lot, like a lot, where you want to be a shop manager for one of these companies that all their salesmen have dressy suits and they charge a lot of money to sell you stuff. And a lot of those companies don't want you doing side work or talking to their customers and then getting the work yourself later. And if you have a master's, they're worried about you pulling a permit and then doing that work or having your own little side business. And I only know of like two individuals where they've worked that deal in with their company and told them, look, I'm going to do what I want to do. And I've already got my own company. And, I'm not interested in your customers. But it's still that weird kind of vibe with the owner. So if you do get a master's and you don't want to have a business, um, it can kind of hurt you. And the way that things are going, man, it's really hard. What's up, Renegades? It's really hard to start a business and run it and be responsible for people and have a family life. It's kind of like this YouTube thing, man. You got to grow it. And it takes a lot of time to grow it. And it takes a lot of time just in general to do anything and grow it. So I don't have enough time to even have a company right now if I wanted to have one. So I don't know. That's not even something that I'm interested in, want to even think about doing. I might do some side work, but that I mean that would be it. Keep it friends and family. Man, friends and family want things for free. So it just depends, man. I could make my own business if I wanted to. I just, man, that's a big step. And then where I live, I'm not allowed to do inspections in the same city. So it's going to put me at least, 30 minutes out wherever I can do work already. Uh, once you become an inspector and you've been here as long as I have, man, you're in it for the long haul. There's no point in doing anything else. The amount of retirement, the benefits that you get. You guys saw how sick I got, and I was able to stay working and just use and just use all of my vacation and sick time and survive. And I promise you, man, if I was working somewhere else, I'd be dead by now with how much time I took off and how much money I would have lost and just the the toll that it would have taken mentally, man. There's no way. I'm like a senior apprentice at your firm at high school. I'll take my test soon. But what do you think of people that are 8-year apprentices and doing journeyman's work? Man, those people are kind of stuck in a trade. Um, they are just stuck. They're very useful though, because companies need those people, right? They're probably really good at what they do. They're really good guys. They're able to do whatever you need them to do, and they're probably reliable. And you can leave them alone. You don't have to babysit them. Um, and they get paid a little bit less, and they don't have any responsibility. And sometimes that would be nice. You know what I'm saying? Like it'd be nice to not have to go to every job, pull out the plans, and freaking figure out what you're gonna do and just kinda skate by. Like, I fully understand that, but that's not something everyone wants to do. Not everybody wants to run jobs. Some people just wanna kick back, and the older you get, the more you'll understand that. I did not understand that until very recently when I came up. If I had a choice to go back, and I could, I get offers all the time. Um, I get stupid offers all the time. I get engineers that wanna hire me a lot and put me through school and do all that too. Um, I might do that. If I was gonna do anything, I'd do that. Um, where I ended up, like, I'm not as good as them, but I'm thinking it's weird to be a J-man when they know more than me. Dude, it's so strange, man, but you know what? Once you start doing it, one day you're just gonna wake up and it's all gonna click. It might have already wo You might have already woken up and one day it just clicked and everything just made sense. And it's so weird when it happens, but one day you're just gonna wake up and you're just gonna be the shit, dude. You're just gonna know it all, and it's all gonna make sense, and you're just gonna start opening your code book, and you're gonna start verifying the plans, and you're gonna have a couple of good catches where the plans are wrong because the plans are always wrong, and you're gonna say, "Oh, we can't run this size wire for this," or "We're missing a set of this," or 350 copper is good for 310 amps each, and they wanted to go for 1,000 amp switchgear or something, and they had 3 sets of 350, and that gave them 930 amps, and you're gonna say, "Man, we can't go to the next standard size because that's over 800 amps," and you're gonna have a really good catch like that, and someone's gonna notice it, and your career is just gonna take off from there because they're gonna know that they can rely on you, you know? Um one day, it's just you're just gonna wake up and everything's gonna make sense, and you're just gonna start running circles around everybody, and they're not gonna be able to stop you. If you got the mindset to keep, going and learning, one day you're just gonna wake up and it's just everything's just gonna make sense. But as far as the masters, man, I'm not saying don't get it because like always try to be building your thing. I'll probably get mine just to get it. Um, Maybe I've got nothing else to do, so I could probably start studying for that. And I guess I'm kinda studying for it now. Um, but I don't need it, I never use it, and I don't even wanna be tempted to use it. I think it would screw me out of a lot of positions, but it could open doors where you can, you're a really good person to talk to, thanks. Man, if you wanna talk, dude, hit me up on my email. It's conductivewood@gmail.com. I'm comfy, but I ain't running circles, but you want to. That's cool. Um Yeah, it's gonna click. I'm trying to think when it clicked for me, man. I think I was redoing a distribution for a museum, and I got my journeymans. I didn't want to tell anybody. 40 amp breaker for 110 volts. There is there is a 40 amp breaker for 110. Um, you don't see it often, but they make one, but you can't put it on a receptacle. It would have to be like specific for some weird piece of equipment. These young people, I'm 26, but I'm dealing with 19-year-olds. It's weird. They can't stay off their phone, dude. This is awesome. This is like I was, man. Um, it's getting even bad out of here. Masters require blueprints. Master requires blueprint. I don't know what the blueprint is. Is that where you're at, Charlton? Blueprint means something. Our licenses are gold here. Reading. Oh, yeah. Well, that's the funnest part is reading the blueprints. I get off, I'm reading the blueprints, man. That's the first thing I do. They're breaking ground at a job site, dude. I wanna go see the plans to find out what the engineer messed up on. They mess up every job, man. Had someone tell me I needed a 40 amp 110 volt breaker to run your welding machine and plasma cutter on 110. I don't like to yell, but I'm having to get that guy and trying to get better at it. Yeah, man, yelling is one thing that I'm really bad at, or I was bad at. Um, I've refined my demeanor over the years. It also runs on 220. I will look into that for you, Ren. As far as a 40-volt receptacle for 110, we can look at the standard NEMA ratings. That'd be a weird cord. I'm not saying it don't exist. I'm just saying I haven't seen it. Um, the 220 is probably a 30 amp. That'd run a lot better too, man. At 220, you're gonna get a better flow on your welder too, man. It just will. Johnson, I'm wearing socks, man. How you smell them? There's a standard that needs to be held, but it just looks bad. Like, at least make it look like you're busy. Oh man, you should see some of the stuff that I see, man. I already know what the state of construction's like. It's wild out there, man. It's wild. I see crazy stuff. It was getting really bad when I started to leave the field, and I felt bad for leaving just because. Yeah, I can use 30 amp 220, but it said it has to be a 50 amp for 220. I can use a 30 amp 220, but it says it has to be 50 amp. Um, you use it on a 30 amp 220, but it has to be a 50. Okay. Or you could do a 110/40. Here's the deal. If you put it on 40 amps, um, you're gonna need number 8. So you already can't use the same size wire you're using. Uh, so you're already gonna be running number 8 in the wall. You may as well run it on a number 6 and just put in the proper stuff, and then you're gonna get a nice bead, a nice flow, all that stuff. I must say you've been a great person to talk to, and I'm hoping to get to where I want to be. You seem like a cool guy to talk with, man. I appreciate it. Trolling. No, no, he's not trolling, Jonathan. Not everyone's an electrician, man. That's probably a serious question. Um, You're probably choking it out though, man. You probably have it set up pretty high, and it's probably tacking pretty hard. If you get a a higher amperage with it, you get a nice bead on there, man. What you need is I get the proper stuff, but I wouldn't. By the time you do a 110 40 volt, 40 amp, I don't even know if you're gonna find a receptacle for it. That'd be a weird plug. You could send me a picture of what the outlet looks like, because there's gonna be a NEMA standard. Like if we go online here and we look at like standard NEMA sizes for plugs, I'll show you how to find it. Um, Hang on. Standard NEMA plugs here. 125. Yeah, man, there is no 40. So this is what you can do. Let's look this up. We got to go to, you might have to go to receptacles, but I think we can go to branch circuits. Let's see. It's not here. It's right here. Here it is here. 40. Okay, check it out. This is what you can do. You can do a 110 50 amp receptacle on a 40 amp breaker. That's why we haven't seen one, because they don't make a 40 amp receptacle. But you're allowed to put it on a 50 amp receptacle. So that's what you can do per code 210.21b3. You take a 40 amp receptacle 110, which would be a number 8. And I'll show you why. And you can put it on a 50 amp receptacle right there. Because you're going to have to go up to, I don't even see a 40 amp rated receptacle on here. Yeah, so you're going to wind up with that. This is what it's going to look like. Check it out. It's going to be weird. You probably don't need the neutral. I don't know what your welder has, man. You might wind up with that. Or you're probably going to wind up with that. Yeah, you probably used a 50. The vehicle chargers are getting crazy, man, because EV, you're supposed to take 125%. So if we were to look up, the installation instructions of an EV charger, you would see that they are continuous load, 43 hours. You got to take it multiplied by 1.25. So if you take a 48 volt max EV charger, you're going to see that by the time you take the continuous load of 1.25, it's actually 60. And you can't put those on number 6 wire. They got to be on number 4 Roman, because that's what it's rated for. So just be careful with plugs and EV chargers and all that stuff. The plug's probably fine because it's a corded plug. But if you're hardwiring stuff, it gets kind of crazy. Number 8, he wouldn't be using a 50 amp breaker. He'd be using a 40 amp receptacle on a 50 amp breaker. Charlton. 40 amp receptacle. 40 amp breaker. 50 amp receptacle. Sorry, microphone's over here. My bad. I forgot where I was talking. right there. 40 amp circuit would be the breaker. 50 amp receptacle. And then the reasons why would be number 8. Oh gosh. Number 8 right there, 40 amps right there. And number 6 is not good for 60 amps, only good for 55. I think because you got a receptacle, you're probably okay. If it's hardwired, it's a little bit different. Just depends on how it's ran, I believe. I think because it's a cord and plug. Hardwiring them, you definitely got to do what you got to do. But the receptacle is just a receptacle. So when it's a receptacle, we're building inspectors, not building expectors, right? So at that point, whatever you're plugging into the receptacle, it's not part of the building. A lot of inspectors forget that. They're like, I know what you're going to use it for. Well, whatever I'm going to plug it into isn't part of the building. So as a building inspector, you inspect what's attached to the building, not what they're going to plug in. Half of the shit that we plug in isn't listed, right? We've got monitors, we've got microphones, we've got all kinds of stuff isn't listed. Yet we plug it in. And that's because it's not part of the building. The second that you attach it, you hardwire it to the building, now it's got to be listed. That's why electric car charger should be hardwired, yeah. I had an electrician come out and run another 220 volt outlet and a dedicated 110 just to run my welder. Didn't sound right, so I didn't let him do it. I had an electrician come out to run another 220 volt outlet and a dedicated 110. The cheapest possible you can do, you can put a 40 amp receptacle. Sorry. You can put a 40 amp breaker, which would be a number 8 Romex, on a 50 amp receptacle per code. And that's going to get you the cheapest way. If you want to do it the safest way, and the better way would be to step it up to number 6, drop it on a 50. But per code is also the safest way. So you can do a 50 amp receptacle on a 40 amp breaker. It would be 240 volt and 120. I take that you're an older gentleman. Yeah. Yeah, when I see 220, man, I don't even think anything of it. Nominal volts. So to recap here, you would be installing, I don't think it has a neutral, so it just depends on what you're running. But man, there's a lot of plugs here. You're probably going to do like that one, a 6-50R. 6-50R would give you 1 ground and 2 hots, and you're allowed to tape the white wire black because it's in a listed multi-wire cable assembly. You could do that. I've seen this one too. You could possibly wind up with that one too. Just depending on what your welder has, man. Well, it's a welder, so I don't think by definition it's a continuous load. And then because it's not hardwired, we can't really determine what it's going to be because it's a receptacle. If you get a permit for it though, it should be GFCI'd. I'm just saying. It should be on a GFCI breaker, technically. I've been using a 30 amp breaker, 220 outlet for a few years. There's no problem. Just getting tired of having to plug and unplug. I got you. Hey, I got 5% battery. I got to end this live now because ending a live not on this phone is almost impossible. I'd have to reset it all. So we'll see you guys later. Take it easy. We'll see you later, Joseph. Hit me up, conductivewood@gmail.com if you want to chat. See you guys in the next one.